Hi, my name is Ed. Join me in reviewing the ESP32-CAM. The following are the flow of the video. So in this video, let's start by Googling what is ESP32-CAM. Alright, enter. In here, we will find online shopping like Lazada and Shopee. Those are the popular online shopping here in the Philippines. The price you will see, it will range from 279 to 400 pesos. They include cam module, of course, and the camera. Some include antenna, and some include FTDI programmer and connector. So ESP-CAM is a low-cost development board with Wi-Fi camera. It allows creating IP cam projects for video streaming with different resolution. So we will check on that resolution dimension. So in here you will have a video, different YouTube channels. A lot of these channels I follow personally, so let's check on them on a separate time. And then below you will have a blog, a random nerd tutorial blog. That's one of the popular blog for ESP32-CAM. Some below we have Instructables, Amazon and Maker Advisor, etc., etc. Of course, the eExpressF website. In this video, we're going to look closely the ESP32-CAM module. So in here, you will have the comparison of the ESP32 module compared to the ESP32 or 8266 Node MCU module and also the ESP-01 module. So in terms of the size, the ESP32-CAM is a bit smaller compared to the Node MCU module and a bigger compared to ESP-01 module. So this one is how the module has it has the built-in camera in here, and then you have at the back you have the TF card holder, and there are some components here, and you have the FPC connector for the camera itself, and you have this they call it the flash lamp. It has a very bright light that could be enough to light your subject for the camera. At the back you will have the the pins, and also the this one's the shield of the ESP32 chip. You have a tantalum capacitor there, voltage regulator, and reset pin that I don't know yet how it works. And so basically that's how this module looks like. In fact, this is my first ESP32 module. Well, the question is always, why do I need to move to ESP32 when I'm enjoying with ESP8266, the smaller version, and also the development kit version? So guess what? The answer is this one has a camera, and you can do a lot of things about using a camera on a module. I don't know, I don't have any project in mind yet, but later as we move forward together, we can discover a lot of things with this module. So we're done with introduction. So the next thing that we need to do is to add the ESP32 package and also the ESP8266 package into the Arduino IDE. Alright, let's add the packages in the Arduino IDE. Go to File, then Preferences, and then you add the packages in Additional Boards Manager URLs. In here, I already added the packages for ESP32 and ESP8266. This one, and the ESP8266 is on the top of the list. This one. Let's click OK and OK, and then let's go to the examples. By the way, we need to assign the board, so go to Tools, then Board, and then you choose ESP32 Arduino, and you go to the AI Thinker ESP2-CAM, because we think that this is AI Thinker board. Then there's no need for us to assign the port because we're not connecting any USB at this time. Then go back to File, then Examples, then look for ESP32, and then Camera, and then the camera web server. We're done with the intro and the ESP package. So let's move on with the camera web server. Sketch contains 4 tabs. The second one is something that we don't know yet. The third one is a bunch of hex code on a string, and the fourth one is, it's a header. I can see that it's being called somewhere here. So since this one is a web server, so we need to assign first the board. So there are a bunch of boards mentioned here, so let's uncomment that and uncomment the AI thinker. We need to assign the Wi-Fi name because this is a web server, and also the Wi-Fi password. Alright, let's check below. As expected, we have a serial begin, and you have the baud rate of the ESP, and below you will have lines of code that we don't know yet. This second tab is something that is not common to a web server. So let's have a quick look on the code lines. I'm wondering if this file is being called in the first tab of the web server. So let's search on it. It doesn't return anything, so let's proceed on the third tab. The third tab has a string declaration. Not really declaration, but it's a string, and the string has hex files inside of it. So I'm guessing this is a file that we don't know yet. So if we move at the bottom, it has more of those hex files. The fourth one is a header. I can see this one is being mentioned on the first tab. So it contains an FL's file, a definition of the GPIOs. It mentions board type. This one is not the board type that we're using. This one is not, and I think this one is the right one. So below you have the GPIO declaration, the pins, etc. So let's go back and compile the sketch. After the compilation, it has a 66% usage of memory. It makes sense because it's a big file. Now we're done with the introduction, the package, and also the sketch. Finally, we're flashing the sketch using FTDI Programmer. I included the connection between the programmer and ESP32-CAM. In order to have a successful programming, make sure that the connection between the FTDI, the 5 volts, the ground, the TX, and the RX are properly connected, and make sure that the GPIO 0 ESP32-CAM is connected to the ground. This will enable the programming state of the module. So we're done with the programming. The IDE will inform you that you need to reset your ESP32-CAM. But before that, make sure that the GPIO 0 is disconnected from the ground. I hope you successfully program your module. So we're done with intro, and adding the package, open the sketch, and programming the sketch. Now the exciting part, testing your module. Make sure you open your serial hub. We can find the IP address of the ESP32-CAM web server there, as highlighted above. Copy this IP address and put it in the browser. There, it will open the toggle settings panel of the camera. This includes resolution, quality, brightness, contrast, and saturation settings. It also includes special effect, AWB, and the gain and other settings. The important buttons are situated at the bottom, namely Get Still button, Start or Stop Stream button, and Enroll Phase button. On top of these are the face detection and recognition that will auto when you click the enroll face button. At this point, you can see the video image. It's not that clear because I was recording during the nighttime, so it was not intentional, but it's good that we have this conducted at nighttime. So at this point, I'm trying to adjust the resolution and adjust the camera to fully capture my image. I have a little light in my room, but still the camera is showing a clear image. At this point, I'm trying to click the enroll face button, but the web server will not allow me. An error message will show requiring me to change the resolution to CIF. After adjusting the resolution, then click the enroll face, and you can see that the camera is identifying me as an intruder. Click again the enroll face and it will change my face into a subject 0. So far so good. Obviously I'm thrilled with the camera's performance, although I'm not expecting a fast camera out of ESP32-CAM, which is a cheap module. Entering subject number 2. Let's see if the camera can detect her as an intruder. There you go. So let's enroll her as a subject number 2. Alright. Notice that the serial log also updates on all of the transactions or activities in the camera. At this point, I'm trying to change the special effect, and you can see that it is also being updated in the serial log. Guys, it feels good to finish this exercise and this video. Now we're going to tackle the issues and errors that I encounter in this exercise. The first issue I encounter is I reversed the connection of TX and RX, so it resulted to timeout waiting for packet header. The second issue I encounter is the GPIO 0. I forgot to disconnect the ground, so that's the reason why the ESP-CAM will not function. The third issue I encounter is I forgot to remove the cover of the camera, so it resulted to a black image. I am fortunate enough that these are just easy error. The ESP32-CAM has a lot of exposed GPIO, so there's opportunity to add sensors and functionality to your ESP-CAM. It also has an antenna. In this video, I don't have any opportunity to add that because of time constraint. Lastly, I would like to thank you for watching this video, and hopefully in the future we will meet again.